In this part, I will go over the details of my plans a little bit more in depth. This information will be very beneficial to three groups. This can help some venture capitalists make millions of dollars. This can help some owners and executives at energy companies make billions of dollars. For politicians, they need to know this information to make informed decisions on energy. This applies to state politicians as well as federal politicians. For the United States, the economic impact is in the trillions of dollars. These three groups are kind of like three players at a poker table. They each can gamble a small amount and win big. Each of these three players needs situational awareness of the other's position. Personally, I want all three to ante up and say, I'm in. I'm not going to stretch this analogy any further because it fails in one way. All three players can win massive pots while playing the same hand. If this hand is played, everybody can win. When you do examine the major details of my laboratory plans, then be aware of this. There are different types of tests and experiments that will be needed. For example, later I will describe for you a proof of physics experiment. It will be expensive. It will prove part of my new physics. I have plans for a number of proof of physics experiments. Personally, the thought of doing them is exciting. However, their purpose is only to better impress the physicists. Another type of experiment will be just for the engineers at my lab. The engineers will need to understand things like how big to make a part or how strong to make a magnetic field, things like that. My engineers will need to test variables and see things for themselves. One of the most important engineering experiments will be a test to see how well the three major systems of these power plant designs will work properly together. Experiments like these are sometimes referred to as systems tests. For example, early on, I will perform important experiments with two systems called the ignition circuit and the confinement circuit. The ignition circuit has a capacitor bank, some lasers, some controls, and the core with its metal sphere and a fusion fuel target. The confinement circuit has its own capacitor bank, some coils, a ring of conducting spheres, and its own controls. Both circuits have a task to perform. One ignites the fuel, the other confines it. Both tasks happen extremely fast. The timing between the two circuits must work together as a system. My physics could be right, my engineering could be right, but if the controls between the two systems don't work together, then the machine will not work. Breakthroughs in physics are useless if the engineering or system fails. This two-system experiment will be expensive, but still, together, these two systems cannot yet be called a fusion power plant. For that, an important third system is needed. It is a special circuit that transfers electricity made in the first two circuits to the electrical grid. Until now, I've never had a reason to name this special circuit, so for this film I have decided to name it the transfer circuit. When the two-system experiment is successful, then that should be considered a milestone that qualifies for further funding. That funding would be used to build a more expensive experiment that will test all three systems together. At some point, when all three systems are tested together, essentially, this will constitute the first fusion power plant for this new class of power plants. Again, system tests are important. Any engineer can cobble together a contraption made up of a variety of parts like wires, capacitors, metal balls, lasers, coils, and so forth. The machine might do one simple thing or even nothing. Engineers actually have a contest to build these Rube Goldberg machines. The key difference here is, if my tests show that these three systems work together, then it will not be a useless contraption. It'll be one of the top 10 innovations in history. Another type of experiment will prove the overall concept of the fusion power plant designs. These are called proof of concept experiments. Think of it this way. It is one thing to come up with a grand unification theory. It is another thing to say that these fusion power plants will make electricity. A proof of concept experiment will prove that these designs can produce electricity. The two-system test I just referred to could also be called a proof of concept experiment. Remember, in the first part of this film, I started off by showing a $40 experiment. This simple, inexpensive experiment means some entity is required to go further, to perform expensive experiments. I want that entity to be my fusion energy lab. Some of the experiments will cost millions of dollars. Earlier, I mentioned the first expensive experiment. It will test to see if my confinement circuit can extend fusion burn times. It will be a proof of physics experiment. One expensive experiment will demonstrate long duration fusion burn times. It will be a proof of engineering experiment. One expensive experiment, the two-system test, will test to see if these power plants can produce any electricity. If successful, this experiment will prove the overall engineering concept. It will be a systems test and a proof of concept experiment. One expensive experiment will demonstrate that the large pulses of electricity that are being made can be safely captured, stored, and then sent out into the electrical grid. That is a three-system test that I refer to. It will be a proof of systems experiment. One expensive series of experiments will demonstrate break-even. By the end of those experiments, the power plant design must make as much electricity as it uses. Mostly that will be a proof of concept experiment. However, in a way, it will also be a proof of economics experiment. Keep in mind, my grand unification theory could be right, while my fusion power plant designs might not work for some engineering reason. On the other hand, my grand unification theory could have an error, while my fusion power plant designs actually still work. Expensive experiments are required because there is no way to be 100% certain until we try them. To quickly recap this topic, initially some experiments will prove physics, some will prove engineering, some will prove concepts, and some will prove systems. Finally, everything must be put together. Actual working fusion power plants must be demonstrated. They'll prove the overall systems design, safety, and economics. In my opinion, one will not be enough. Therefore, I envision that my lab will build at least 4 working fusion power plants. I have already mentioned one of these 4. It is in the second phase of my plans. It is the one that first tests all 3 systems. It could be considered the first fully functional fusion power plant. It could also be the one that demonstrates break-even. As I mentioned earlier, our break-even device produces at least as much or slightly more energy than it uses. The final 3 fully functional fusion power plants should produce more energy than they use. They will be really expensive experiments. In essence, they'll go beyond proving you can safely make electricity with fusion energy. They'll prove that you can make a lot of money with fusion energy. After that is proven, government funding is no longer required. After that, my laboratory really wouldn't need to do that much more. The energy companies would take over. They would raise millions of dollars through venture capitalists. They would fund their own research and development. Utilities would also start raising money and placing orders with the licensed manufacturers. So, to recap, that was a short explanation of the types of experiments I plan for my lab. A moment ago, I mentioned really expensive. What does that mean? At this time, I really can't be sure. I will need to hire a number of experts and do a number of expensive experiments before that can be nailed down with any certainty. This is one of the reasons I would like 3 staged grants. I'll talk more about this idea of 3 stage grants later. At this time, let me just say my best estimate is each demo fusion power plant will cost roughly about $100 million. Demo 1 might only be about $75 million. Demo 2 might be about $100 million. And Demo 5 might be about $125 to $175 million. In total, if it gets to the 3rd phase of my plans, I estimate the 3rd grant would need to be about $350 million. That should be roughly what will be required to build all 3 of these demo fusion power plants. Earlier, I mentioned the 3 demo power plants will have 3 different diameter spheres. Here's that graphic again. This diameter will affect many details. It will affect the cost of the devices. For example, imagine how much copper they'll need. It will affect their frequency. This diameter will play a role in determining how much electricity they can produce. Think of it this way. Power plants have a power rating. It is usually described in megawatts. Think of this number as how much electricity the power plant can safely produce. Each of my demo power plants will use a number of conducting spheres. The diameter of these spheres and the number of spheres used will determine how big the power plants will be, how expensive they'll be, and how much electricity they can safely produce. Thus, I expect their power rating will be a function of this diameter. Again, these 3 demo power plants would be built in the 3rd phase of my plans. In a way, these 3 demonstration power plants are experiments. However, at this stage, this will be way beyond proving the physics or basic engineering. The 3rd phase will not be about making electricity. That will already be proven. At this stage, it will be all about proving the overall systems engineering and, most importantly, that you can safely make money with them. You might call these experiments proof that you can make some profit experiments. If you can't safely make money with them, then they will not be built.